Hi there, I got a question about how to divide polynomials by monomials. Remember what that means? Polynomials is when you have an algebraic expression with more than one term. A monomial is where you have just one term. So let's look at an example we have here. We have 12n to the 6th minus 30n to the 5th plus 168n to the 4th. And notice I have parentheses around all that, divided by 6n to the 3rd. Well, that's the same thing as saying 12n to the 6th minus 30n to the 5th plus 168n to the 4th all over 6n to the 3rd. Remember, that division is the same thing as the fraction bar. Now, when you have an expression on the top, like a polynomial on the top, we can split that up, right? So now, but remember, you have to have only a monomial on the bottom. So that's the same thing as saying 12n to the 6th over 6n to the 3rd minus 30n to the 5th over 6n to the 3rd plus 168n to the 4th over 6n to the 3rd, or cubed, however you want to say that. So now that we have these three different division problems, because now we have a monomial divided by a monomial divided by a monomial, and monomial divided by a monomial, now we can look at those individually. When we work those, what we do is we either reduce or divide the numeric part, and then we work separately on the variable part, right? So let's take this over here. So let's first look, we had 16, let me copy that down. 16, you know what? I just realized something. I copied that wrong. That should be a 12, not a 6. 12n cubed, sorry about that. So we have 12n, wish I could just copy that over. 12n to the 6th over 6n cubed. Let's just look at that part. That right there, so what we're going to do is take the number part, 12 divided by 6, and that gives us 2 on the top, right? So that's the same as 2 over 1, or just 2. Then we look at the n part. Remember, when we're subtracting this, so if we have just n to the 6th over n to the 3rd, that's a terrible 6, sorry, and a terrible 3. Let's look at that, 6 and a 3. There we go. When you have a variable, the same variable, like if we had an x and an n here, we could not do this. But since we have an n and an n, what you can do then is in your dividing, you subtract the exponents. So this is the same thing as saying n to the 3rd, right? Because 6 minus 3 is a positive 3. So that's n to the 3rd on top, or over 1. So that means that 12n over to the 6th over 6n to the 3rd is 2n to the 3rd over 1, which is the same thing as 2n to the 3rd. All right, so let's look at that second part. We had negative 30n to the 5th over 6n to the 3rd. Again, since the exponent on the top is bigger than the exponent on the bottom, that means we're only going to end up with an n term in the top here. So first we're going to start with negative 30 divided by 6. Negative 30 divided by 6 is negative 5 over 1, right? And then we have n to the 5 minus 3, which is the same thing as 2, right? And when we're divided by 1, that's just the same thing as saying negative 5n squared. All right, now the last one we have is 168n to the 4th over 6n cubed. Again, I'm just breaking this up to show you how to do it in parts if you're having a hard time doing it all together. So here, first we need to do 168 divided by 6. 168 divided by 6, gives us 28. So we're going to have a 28 in the top, and we're going to put a 1 on the bottom there just as a placeholder. And again, our exponent on top is bigger than our exponent on the bottom. So 4 minus 3 up there is just n to the first power, which is just n. So this gives us 28n. So now when we put those all together, we now have 2n cubed minus 5n squared plus 28n. Now, Notice that none of these are like terms because all the exponents are different on those variables. So we can't combine anything. So that is our final answer. Okay, so that's one example. Let's look at another example. Let's see what we've got here. All right, let's take a look at this one. I've got negative 36 c to the 6 d to the 4th. So this one's a little more complicated. We have two variables. Minus 27 c squared d to the 4th minus 108. Sorry, I have a hard time writing on the tablet, so please forgive. If you have a hard time reading anything, just point it out and I will let you know. All of that divided by negative 9 d to the 4th. So I'm going to tell you right off the bat, since there's only a d here and there's a c and d in all these terms, nothing is going to change with your c terms. All these c terms in your answer should be exactly the same as they are here because we're not changing the c part because there's no c in the denominator. Okay? So let's write this as a fraction. And we're going to go ahead and split it up. Well, we don't have to. It doesn't matter. It depends on how you feel more comfortable. But I'll split it up now just to make it really clear. So we have negative 36c to the 6th d to the 4th minus 27c squared d to the 4th minus 108c d to the 4th all over negative 9d to the 4th. Now another thing I see, these are all negative and this is negative. When we have a negative divided by a negative, we're going to have a positive. So you know right off the bat, all your C terms are going to stay the same, or not your C terms, the C variable exponents aren't going to change. And all these are going to be positive in the end. Without doing anything else, that you should know. So if you end up with a different answer, then you know there's something off. So now we're going to break it up. So we have negative 36c to the 6th d to the 4th over negative 9 d to the 4th minus 27 c squared d to the 4th over negative 9d to the 4th. Another way to look at this is plus and a negative. Remember, that's the same thing. So however you think of it easier, you can look at it other way. We can do it plus also negative 108. That way, when you're looking at these negatives, it's a little easier. cd to the 4th. Now, one thing I didn't notice right off the bat that I notice now, not only is there a d in all these, but the exponents are all the same. So when you have d to the 4th divided by d to the 4th, what does that equal? I don't know. What's 2 over 2? That equals 1. Whenever you divide a number by itself, you get 1. Well, the same thing goes for variables. So all of these that go to 1, this d to the 4th over d to the 4th, d to the 4th, d to the 4th, those all equal 1. If those all equal 1, these terms all just go away because you're multiplying by 1. So now we have, in this case, we have negative 36 divided by negative 9. Negative 36 divided by negative 9 is a positive 4. And it's like the same as 4 over 1, which is the same as 4, right? So now we have 4, and we have that c term, c to the 6th left. Now we have plus negative 27 divided by negative 9. Again, that gives us a positive 3. And we bring that c squared down. Again, there's nothing on the bottom left here because 27 divided by 9 is 3. Now, if let's say we had negative 9 over 27, let's say we had negative 9 c squared over 27, then you would end up with c squared over 3. Okay, the only reason we're not ending up with that here is because the number on the top is bigger and they divide evenly. All right, so that's your first term, your second term. Let's look at the third term. We have negative 108 divided by 9. And that's going to give us, or excuse me, negative 108 divided by negative 9, which is going to give us a positive 12. And we're going to carry down that c term. Again, none of these are like terms because the variable exponent, that c to the 6th, c squared, and c to the 1st power are all different. We can't combine any terms. So that right there is our final answer. All right, I hope that helps you guys. The main idea when you're dividing a polynomial by a monomial is that you need to switch it from the horizontal with the division bar to switch it to a fraction problem and then break it up into each of the terms. Okay? If you guys have any other questions, let me know.